All right, everyone, let's look at lesson 1 from unit 2. Unit 2 talks about matter, so lesson 1 is going to talk about the types of matter that there are. First, we've talked about matter before. It was in your definitions, so let's talk about what it is again. Matter is anything that has a mass and takes up space. We know the fact that it takes up space is known as its volume. So anything that has mass and takes up space, we in chemistry define that as matter. Things that are not matter are things like light, or heat, or sound. Those are not matter. Matter can be classified into many different categories. You have this overarching concept called matter. Then you have two things. Can it be physically separated? Either yes or no. If it can be physically separated, it's a mixture. If it cannot be separated, it's a pure substance. And then underneath mixture, we have two umbrellas. We have homogeneous mixture and heterogeneous mixture, which you might have heard before in another science class. Or if it's a pure substance, it can be a chemical compound or an element. So let's go into what these things are, particularly in more detail. So let's start off with pure substances. Pure substances have a definite composition. Each substance has exactly the same composition. They have definite properties. So those are the two big things that describe what a pure substance is. Pure substances are made of only one type of atom, and we call that an element. So example, iron, gold, oxygen, those are all pure substances because they only have iron atoms, gold atoms, or oxygen atoms in them. If you have two or more types of atoms, then you're talking about a compound. An example of that would be like salt, sugar, or water. Those are not made up of just one kind of atom. They're made up of multiple kinds of atom. For example, salt is made up of sodium atoms and chlorine atoms. Sugar is composed of carbon, hydrogen, and oxygen atoms. And water is made up of hydrogen and oxygen atoms. So those are atoms, more than one kind, that are being bonded together to form a compound. Elements are substances that cannot be broken down. They are made up of all of the same atoms. Elements we're going to recognize them in this class because of their symbols. They always have one capital letter, and the second letter is lowercase if they have a second letter. So for example, hydrogen, nitrogen, and lead. Hydrogen, the elemental symbol for hydrogen is just an H. The elemental symbol for nitrogen is just an N. There's one capital letter in each of those. And for lead, there are two letters. The first one is always capitalized, and the second one is lowercase. So as we can see, lead, the symbol for lead, the element of lead, is Pb. The Pb comes from the Latin name of lead. That's why it's not Le, or something that you would be like, oh, that would make more sense. If we have monatomic elements, now this is where it could get a little bit confusing, so make sure you're paying attention. And if you don't understand something, make sure you pause, rewind, and go back over. A monatomic element is composed of a single atom, but they're not bonded to each other. So for example, sodium. These little circles here are all sodium atoms that are floating around. A diatomic element is an element that is bonded together, and it has two atoms of the same element that are bonded together. So for example, hydrogen is a diatomic element. These two H atoms are bonded together. Elements that exist as diatomic molecules, there are 7 of them. And they spell Brinkel, B-R-I-N-C, and then Hoff. So if you hear me refer to Dr. Brinkelhoff, that's who we're talking about. So they are bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. These you need to memorize. You need to know what the 7 diatomic molecules are on your periodic table. I'll say it again. Dr. Brinkelhoff will help you get there. So bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Those are the 7. If you don't want to just straight up memorize them, you can use your periodic table. The 7 diatomic elements on the periodic table form a 7. And then the last one that's not included is hydrogen all the way over here on the left. But here are your 7 diatomic molecules. Pretty nifty. So now let's talk about compounds. Compounds are made up of two or more different atoms, and they are chemically combined. They have a fixed composition, and they can be separated chemically back into simpler substances. They are represented by two or more different capital letters. So, for example, this is the molecule of carbon dioxide. So carbon is in the middle, and we have two oxygens on either side. So this is what the molecule would look like. Now, when you're talking about formulas or compounds, you're going to have subscripts. Subscripts are the little numbers that follow an element symbol, and that indicates the number of atoms of only that element in the compound. So what does that mean? So for example, in this formula, which is the formula for water, H2O, that means that little 2 means that there are two H's, and since there's nothing here, we know in chemistry that means there's a 1 there, and there are 1 oxygen. So if we draw this, we'd have a oxygen, which would be this big white circle, and then the two little black circles are the two hydrogens. Same thing for carbon dioxide. We have 1 carbon and 2 oxygens. So in this picture, carbon would be in the middle, and the 2 oxygens would be on either side. Coefficients are the big numbers that you'll see in front of a formula. They indicate how many atoms or molecules that you may have. So for example, if we were to write 3 in front of H2O, that means that there are 3 molecules of the compound H2O. So in our pictures, we have 3 of these because we have a 3 here. So let's look at this practice. How many molecules of water are indicated by the formula? Pause the video and let's look at that when you're ready. Great, what'd you come up with? You should have said that there are 2 molecules of water because this 2 in front of the H2O means that there are 2 water molecules. Let's look at this practice. How many atoms of hydrogen and oxygen are there in a molecule of water? Pause the video and unpause it when you're ready. Great, what did you come up with? You should have came up with there are 4 atoms of hydrogen and 2 atoms of oxygen. The 2 here times this 2 would give us 4 atoms of hydrogen, and this 2 times the 1 oxygen would give us 2 atoms of oxygen. Now let's talk about mixtures. There are 2 or more different substances that are physically combined, and they have varying composition. Now remember, under that umbrella that we called mixtures, when we looked at that chart at the beginning of this lesson, there are 2 different types of a mixture. The first one is homogeneous. A homogeneous mixture is has substances that are uniformly formed. All solutions are homogeneous. So for example, if you have a salt water solution, and this AQ means dissolved in water, you cannot tell the difference between the water and the salt. And you cannot physically separate them. A heterogeneous mixture are substances that are not uniformly formed. So for example, oil and vinegar, sand and water, you can definitely see where the sand is and where the water is. Or if you were to look at, for example, cat vomit, you can tell what the different pieces are. So that's a heterogeneous mixture. So let's do some practice. Classify the following as a compound, an element, or a mixture. Classify gold, table salt, and sand, and we'll go over all of these when you're ready. Great, what did you come up with? Well, when you think of gold, AU, you should have been like, wow, there's only one kind of element here. So that has to be an element. When you're looking at table salt, you should have looked at your formula and said, wow, there's two different elements in here. And when we talked about it, 2 different elements that combine, that is a compound. Sand is a mixture. There's a whole bunch of stuff when you look at sand. So today, we learned about types of mixtures. Tomorrow when we come into class, we're going to talk about these 2 check your understandings. So what types of mixtures are each of the following? Homogeneous or heterogeneous? And how many oxygen atoms are there in the compound Na2CO3? See you tomorrow.